Hello guys, and welcome to our very first video. So today we're going to start by taking a look back at stuff we've done earlier on in this unit. If you guys remember correctly, we used squares to represent x squared. So what I'm going to do is I'm going to bring up 4 different x squareds. And then we use lines to represent x, so I'm going to bring up 3x. And dots are going to represent constants. So I'm just going to make these a little red to make them negative. And then here I have 2x squared, and here I have 2x's, and then I'm adding on one constant. So the thing that we need to notice here is that we have squares, we have lines, and we have circles. So I have 4 squares here, and I have 2 squares here. So what I can do is I can take these squares, and I can add them together. And when I add them together, I don't change the fact that they're squares. I just add them together to get 6x squared. Next thing I want to do is take these lines and add them together. Whoop! So now instead of having 3x for lines, I have 5x for lines. Lastly, I have -2 and +1, and that gives me a -1. So what I'm trying to show you here, guys, is that when we combine like terms, when we add them together, that is when we just add the coefficient. We don't change the exponents. We don't change the like term that's being added together. That's what we're going to be doing today. Basically, all we're doing is combining like terms. So let's take a look at what adding and subtracting polynomials mean. You have 2 options. You can group them horizontally, or you can add them vertically in columns. And we'll go more in depth as to what each of those means here in a couple of minutes. When we're adding polynomials, basically all you are doing is combining like terms. So think back to the first day of this unit. Remember what we did. And when you do that, you will you'll know what we're doing today. Okay? The last thing I want you to make sure you remember before you do this is that your answers need to be in standard form. They need to go from largest to smallest. Your exponents, your largest one is first, your constant is last. So make sure you're putting your answers in standard form. So let's take a look at number 1. So for number 1, all we're doing just to start off with is reminding ourselves how to combine like terms. So I look here first and I see that I have 4x cubed and I have 3x cubed. Okay, so now that I have those two together, they're both like terms. So I'm going to add them together and I'm going to make that 7x cubed. Notice I didn't make that 7x to the 6th. I did not add the exponents. You are not adding exponents here. When we combine like terms, we keep the variable as is and add the coefficients. That's what we're working on right now. The next set of like terms I see is plus 8x squared minus 5x squared. They're both x squared, so I can add them together. So plus 8x squared minus 5/8x squared is going to give me plus 3x squared. Again, I'm not changing the exponent, I'm changing the coefficient. I'm adding the coefficients together. That's what we did when we started adding like terms. Next, I have negative 3x plus 5x. Those are my next set of like terms. So I'm still just going to have an x, but my coefficient is going to be 5 minus 3, which is 2. So I'm going to make that 2x. The last thing I need to do is take 8 minus 12. When I do that, I get negative 4. So my answer then is in standard form. I'm going from my largest exponent to my smallest exponent, which is my constant. Okay, so we're done with that one. My answer's in standard form. All my like terms are combined. Let's take a look at number 2. Number 2, we're going to go back to combining like terms. So I have 3x cubed minus 2x cubed. So we're going to subtract those. 3 minus 2 is just 1x cubed or just x cubed. Okay? But Miss Humbert failed to see that there's that 5x to the 5th there. That 5x to the 5th actually needs to come before that x cubed because it's a larger exponent. Remember, as I'm writing this down, I'm trying to put my polynomial into standard form. So now I have those two taken care of. Next, I say I have minus 2x minus 4x. That's my next lowest exponent. So negative 2x minus 4x gives us negative 6x. Lastly, I have 4 plus 5, and that's going to give me plus 9. So as you can see, my answer is in standard form, and the exponents are going from largest to smallest. So I am done with these two. What I want you guys to do now is just to pause the video. I want you to try these two on your own. I highly suggest trying them because they'll probably show up on your quiz at the end of this video. All right, so let's take a look. First, these are two methods. So the first method is horizontally. When you are doing things horizontally, all you do is you line the terms up straight across. And then you're just going to combine like terms, just like we did in the previous problems. So I'm going to take 4x squared plus 2x squared, and that gives me 6x squared. And then I have 3x plus 2x, that gives me 5x. All I'm doing here is combining like terms. Lastly, I have negative 2 plus 1, and that gives me minus 1. This polynomial might look familiar. It's the one we did at the beginning. And what I wanted to show you is that when we're adding polynomials together, I'm not trying to take squares and make them anything else but squares. My squares are staying squares. My lines are staying lines. My circles are staying circles. All we're doing is combining like terms. The second method, and the method that I actually like better, is the vertically method. So we line the terms up vertically, and we put the terms into columns so that we can just add straight down. So here I have 4x squared plus 2x squared, and I get 6x squared. Then I have 3x plus 2x down the column, and I get 5x. Then I have negative 1 plus 2, and I get minus 1. So again, just adding straight down those columns. If at any point you feel like I'm going too fast, go ahead and pause the video. Take a second to look at things. Don't move on until you're ready. Okay, let's try this out. So let's look at number 5. Number 5, our first polynomial is in standard form. So I'm going to go ahead and write that polynomial down. And I'll tell you that during the notes, I'm going to use the vertical method. It is up to you which method you want to use. This is just the one that I prefer to use. So I have 3x squared minus 4x plus 8. This next polynomial that I have is not in standard form. I like putting my polynomials out in standard form when I write out my columns so that my answer when I'm done is in standard form. So what I can do now is I'm going to take this negative 7x squared and I'm going to put it in my x squared column. I'm going to take this plus 2x and I'm going to put it in my x column. I'm going to take this minus 5 and I'm going to put it in my constant column. Now that I've lined up all of my columns by their like terms, I can go down and I can just add each column. 3x squared minus 7x squared gives me minus 4x squared. Negative 4x plus 2x gives me minus 2x. 8 minus 5 gives me plus 3. So all I did was add down those columns. Check, is my answer in standard form? Yes, it is. So I'm done. Let's take a look at number 6. So number 6, that first polynomial is in standard form, which is great. So we can go ahead and write that down. 5x squared minus 3x plus 4. That second polynomial is not in standard form. We need to put it in standard form. So I'm going to have a column of x squareds. I'm going to have a column of x's and a column of constants. So I just took that second polynomial and I lined up my columns. So I had an x squared column, an x column, and a constants column. So I can take and I can add these together. 5x squared minus 3x squared is going to give me 2x squared. Again, remember guys, we're not changing the exponents on these. When we combine like terms, we don't change the exponents. Negative 3x plus 6x is going to give me plus 3x. 4 minus 3 is going to give me plus 1. All we're doing is adding down the columns. Again, if you need more time to take a look at this, go ahead and pause that video. So let's talk about subtracting polynomials. When you're subtracting polynomials, you go through and you change the signs of everything following the minus sign. This is something I'm going to make you do. I see so many students try and just do all the negatives in their head, and that's where you make mistakes. So what I want to do is I want to take a step back and I want us to actually distribute that minus sign all the way through so we don't make as many mistakes. So what does that look like? Well, let's set up our columns for this first one on number 7. So we have 4g cubed minus 5g. Now I'm going to actually be subtracting off 2g cubed plus 4g. Okay, so now what I'm talking about is when we're subtracting off, I want to change this to a plus. And when I do that, I have to change the signs of everything inside of that polynomial. So now that I've changed everything in the polynomial after the minus sign, remember it's only after the minus sign, I can go through and add my columns. Okay, I've changed the signs, so now I can add my columns just like we did on 5 and 6. 4g cubed minus 2g cubed gives us 2g cubed. Minus 5g minus 4g is minus 9g. Last thing I want to check, is my answer in standard form? Yes, it is. So I can move on to the next one. So when I start number 8, I notice that that first polynomial isn't in standard form. So when I go to make my columns, I want to go ahead and put that in standard form. So I have 13n cubed plus 3n squared plus 5n. So now that polynomial is in standard form. Now we're subtracting off that second polynomial. So I have a minus, and I'm subtracting off something from that whole polynomial. So I need to just change the sign of everything. Well, first let's just write that polynomial down. Well, I want to take this 4n cubed, and I want to put that in my n cubed column. I want to take this 7n, and I want to put that in my n column. If you guys notice, there is no squared column. That's okay. There doesn't need to be. So once I have that polynomial written out in my columns, I'm going to go through and change the signs. And so then I have minus 4n cubed minus 7n. So now that I've changed the signs of the polynomial following the minus sign, I can go ahead and add my columns. So I have 13n cubed minus 4n cubed. That is going to give me 9n cubed. Notice that this 3n squared is not being added to anything. Since it's not being added to anything, it's kind of like it's being added to 0. So it just comes down to that total. Don't forget about it up there. Then I have 5n minus 7n, which is a negative 2n. You also could have written that as minus 2n. Both answers are equally correct. So what I want you to do next is I want you to try 9 and 10. The answer key is up front. If you need a little help solving them, you can look at that note sheet. Again, you want to be doing these problems because they sometimes appear on that Schoology quiz that we take after our video. What I want to do next, I just want to briefly set up this word problem so that you guys can go ahead and solve it on your own. So it says the total number of public school teachers T consists of two groups, elementary E and secondary S. From 1992 through 2003, the number in thousands of secondary teachers and total teachers could be modeled by the following equations, where n is the number of years since 1992. So S is equal to 29n plus 949, T is equal to 58n plus 2,401. So here's what I will tell you. The number of elementary school teachers E is equal to T minus S. So let's put that out. So T is 58n plus 2,401 minus the secondary teachers, which is 29n plus 949. So go ahead and set up your columns on that one. I'll walk through it with you. So we have 58n plus 2401. Then we're going to be subtracting 29n plus 949. So I'm going to go ahead and leave it to you at that. You go through and you subtract out those columns and get what the equation is for elementary school teachers. This concludes your first video. So once you've gone through the extra problems and you feel ready, you can go ahead and take the quiz associated with this video. Once you're done with that quiz, go ahead and grab your homework. Thank you for listening.